today we will discuss with the 2 points. One is the principle of reversibility of light, and the second one is the lateral displacement. So the 2 figures I have drawn here. The first figure shows the principle of reversibility of light, and the second one, this figure, shows the lateral displacement. So we are going to discuss the 2 things now. The first one is the principle of reversibility of light. Now, according to the principle of reversibility of light, if the reflected ray or refracted ray is reversed, both the reflected as well as refracted rays are reversed, it will retraces its original path. That means the light will follow the same path. Okay. If the reflected ray or refracted ray are reversed, it will retraces its original path. So how to understand about the principle of reversibility of light? So this is the principle of reversibility of light, that is a reflected or the refracted ray is reversed, it retraces its original path. So for that, you follow this figure here. NO and S is the normal, which is perpendicular. AO is the incident ray. OB is the refracted ray. Then I is the angle of incidence and R is the angle of refraction. So what is the angle of incidence means? The angle made by the incident ray with the normal. AON is the angle of incidence. BO and S is the angle of refraction. Now let us consider a ray of light AO is incident at point O. The incident ray AO gets a ray of light is incident at a point O, separating the 2 surface, air and water by XY. XY is a separating surface. Okay, the 2 medium are there, air and water. Okay, and the ray of light is coming from air and entering towards water. So AO is the incident ray. So once the ray will fall on this at a point O, that is on the separating the 2 media on the line XY, the ray of light will get refracted, and refraction takes place and it bends closer to the normal. Okay, it bends closer to the normal. So why it is bending closer to the normal is because the speed of the light in water is less as compared to the speed of the light in air. Okay, so automatically what will happen? The speed of the light in air is more. Once it enters into the glass, the speed of the light it decreases, and therefore the bending of light takes place. Okay, the speed of the light will change. So bending of light takes place, and here the bending of light takes place closer to the normal. So OB is the refracted ray. Now this refracted ray now falls on the mirror which is placed in the water. Now when this refracted ray falls on the mirror in the water, placed in the water, the ray of light will be reflected back. Okay, OB is the refracted ray. Now the same ray of light will again reflected. So reflection takes place here, since it is falling on the mirror. So when it falls on the glass of the mirror, reflection takes place. So OB is the refracted ray. When it falls on the mirror, then the same ray of light will be reflected back to the same direction. That means BO is the refracted ray. OB is the refracted ray. BO is the reflected ray. And it falls at the point O. It comes at the point O, and from the point O, the ray of light has to get refracted. That means the refraction should take place, because the ray of light is passing from the denser medium, that is from water to air. So the refraction has to take place here. So now when the refraction takes place here, so OA will be the refracted ray. So that means BO is the refracted ray, OA is the refracted ray. So when the reflection and the refraction is taking place, they will follow the same path. That means retraces its original path, which has been stated according to the principle of reversibility of light. So therefore this explains this diagram, the figure or the ray of light explains the principle of reversibility of light. Second point, now the lateral displacement. Now the 2 surfaces are there, the 2 medium are there, air and glass. Now the light is passing from air to glass. Okay, so NO and S is the normal, NB and is again another normal, AO is the incident ray, OB is the refracted ray, and BC is the emergent ray. Remember that BC is the emergent ray. Okay. Now let us consider a ray of light coming from a source. That means a ray of light is incident at a point O. That means AO is the incident ray which falls on the separating the two media, air and glass. Now the light has to pass from air to glass. So when it enters inside the glass, the ray of light gets bent towards the normal. Okay. So AON is the angle of incidence I1. Then BON is the angle of refraction R1. Then again the ray of light, it falls. Okay. OB is the refracted ray, and this refracted ray again falls on another medium, another surface, and from that surface the ray of light has to come out. That means it has to come from glass to air. So when this ray of light will come from glass to air, again another refraction takes place here. Twice the refraction is taking place. Okay, first refraction is OB, another refraction is BC. But when the refraction is taking place here, the ray of light is coming out of the glass slab. It is not remaining inside the glass slab. It is coming outside the glass slab. Now this refracted ray, now we call it as emergent ray. So BC is the emergent ray. That is the ray which comes out from the glass slab after refraction. That is the emergent ray. Okay. So BC is the emergent ray. OB is the refracted ray. OE is the incident ray. Okay. Then again CBN is the angle of emergence. This is the angle of emergence. Okay. And therefore what will happen is that now the angle of emergence is equals to the angle of incidence. That means angle I1 is equals to R2. This angle of emergence will be same as that of angle of incidence, but here the angle will be different. Since the bending of light is taking more. So more the bending of light, more the refracted ray will come closer to the normal. So that is why R1 is not same. It is not same. So R2 and I1 is equal. So therefore from this figure we can say that the angle of incidence is equal to the angle of emergence. Next point, now this incident ray, when you draw the original path of the incident ray, actually the incident ray has to pass in this direction. But here when it enters inside the glass slab, it is bending closer to the normal due to the change or difference in the speed of the light in the two different mediums. So therefore, when you draw the original part of the incident ray, okay, and the emergent ray, the perpendicular distance between this original part of the incident ray and the emergent ray, this distance is called the lateral displacement. So lateral displacement is the perpendicular distance between the original path of the incident ray and the emergent ray is known as the angle of is known as the lateral displacement. Okay, and angle, that is the incident ray AO is parallel to BC. Again the next point, AO, the incident ray AO is parallel to the emergent ray BC. Then the emergent ray R2 is equals to the angle of incidence, that is I1. That means the angle of emergence is equals to angle of incidence. Incident ray is parallel to emergent ray, and the original path of the incident ray and the emergent ray is known as the lateral displacement. So lateral displacement is the perpendicular distance between the original path of the incident ray and the emergent ray is known as the lateral displacement. Okay, so in the next class we will come to the factors affecting the lateral displacement. Thank you.